Hey everyone, ready to dive into the world of engineering? Let's get started. How to design a low-pass filter. In this video, we'll explore the fascinating world of low-pass filters and guide you through the design process. Low-pass filters play a crucial role in audio and signal processing by allowing low-frequency signals to pass while attenuating higher frequencies. This is essential for enhancing sound quality, reducing noise, and ensuring clarity in various applications. Whether you're an audio engineer, a hobbyist, or simply curious about electronics, understanding low-pass filters can greatly improve your projects. We'll cover real-world applications, including music production, telecommunications, and everyday devices like speakers and headphones. Join us as we break down the principles and techniques that will help you design an effective low-pass filter. Define the purpose of your low-pass filter. The first step in designing a low-pass filter is to clearly define its purpose. Consider your specific application, whether it's for audio processing, signal conditioning, or another use case. For example, in audio applications, you might want to eliminate high-frequency noise while preserving the richness of lower frequencies. To achieve this, you need to determine the cutoff frequency, the point where the filter starts reducing higher frequencies. Defining your purpose and cutoff frequency is critical, as it directly impacts your filter's effectiveness. This foundational step ensures that your design meets your specific needs. Choose the right filter type. Selecting the appropriate filter type is essential. There are two main categories. 1. Passive low-pass filters. These include RC resistor capacitor and RL resistor inductor filters. 1. They are simple, cost-effective, and require no external power but may have performance limitations. 2. Active low-pass filters. These use operational amplifiers, op-amps, and offer higher performance, gain, and improved frequency response. 2. Common types include first-order and second-order filters, which provide steeper roll-off characteristics. Passive filters are easier to design, while active filters offer better performance and signal integrity. Consider your project's requirements before making a decision. Calculate the cutoff frequency. Calculating the cutoff frequency is a crucial step in filter design. For an RC low-pass filter, the formula is FCIL1 2PRC, where 1 is the resistance, 2C is the capacitance, 3 FC is the cutoff frequency. For example, in audio applications, cutoff frequencies can range from 20 Hz to 20 kHz, while in signal conditioning, they may vary from a few Hz to several kHz. By adjusting the resistor and capacitor values, you can fine-tune the filter to meet your specific needs. Select the right components. Choosing high-quality components ensures your filter functions correctly. You'll need 1. Resistors and capacitors for passive filters. 2. Operational amplifiers. If designing an active filter, refer to your calculated cutoff frequency to select suitable resistor and capacitor values. Also, consider component tolerances. Tighter tolerances lead to more consistent performance. High-quality components will improve the reliability and accuracy of your filter. Build the circuit. Now it's time to assemble your low-pass filter. Follow these steps. 1. Refer to the schematic diagram of your chosen filter type. 2. Gather the necessary components. 3. Connect the resistor and capacitor correctly, paying attention to polarity if using polarized components. 4. If using an op-amp, connect it as specified, ensuring proper power supply connections. For safety, always disconnect power before making adjustments. Use insulated tools and verify all connections before turning the circuit on. Test and optimize your filter. Testing your low-pass filter ensures it performs as expected. Use tools like 1. Oscilloscopes to visualize the signal output. 2. Frequency analyzers to measure attenuation at different frequencies. Apply an input signal and observe the output. Compare it to your design expectations. If needed, troubleshoot by 1. Checking connections for accuracy. 2. Ensuring component values match your design. 3. Looking for unwanted noise or distortion. By fine-tuning your filter, you can optimize its performance for your application. In this video, we covered the essential steps to design a low-pass filter. 1. Defined the purpose and cutoff frequency. 2. Selected the appropriate filter type. 3. Chose suitable components. 4. Built and tested the circuit. Low-pass filters are crucial in many fields, from audio processing to signal conditioning, helping to improve clarity and quality. That's all for today. Stay tuned to TechBlueprint for more clear and practical engineering content. See you in the next video.